Okay, Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin, wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'al hazna idza syi'ta sahla. Okay, Assalamualaikum and a good day. So for this video, I will continue from subtopic 4.3. Okay, so okay, this is the second video for the chapter 4 as the load, and I will be continue from the subtopic 4.3. Okay, let me fix this one. Okay, so we have gone through the process on how to calculate the displacement, or sometimes we call it deformation, where we apply an equation of delta equal to PL over AE. So normally I will remember like this way: delta equal to pi, okay, PL over AE. So of course in the examination, there are only some equation will be provided. So you have to memorize the equation. Okay, so what method or what way that you want to memorize is up to you. So the one that I use is ply lah. Okay, so let's continue to the next subtopic, which is the principle of superposition. Okay, right. So what is the principle of superposition? Actually, there is a way that we can simplify the equation, or we can solve the problem. And this principle is actually to simplify the stress and displacement problems by subdividing the loading into components and edit the results into it. So if you have this condition, for example, the first figure, which is figure A here, you can see the rod is totally bending up to 45%, for example, 50%. Okay, so the first one, which is, sorry, something error here, I cannot write. Okay, hey, something error. Let me fix this one. Okay, let me try again. Hey, what happened to my pen? Yeah. Oh no, battery lah. Okay, never mind. I will use my hand lah. Okay, so the first one that you see here is the first figure that shows the rod is bending downward when we have the external force of P. Okay, we have P here. Okay, and the best thing is that from this complex deformation structure, deformed body, we can make it two different figures like this one. So this is the process where we simplify the problem, or we simplify the method to find the D, okay, to find the stress, for example. So the first one, of course, at a certain distance, okay, the displacement is like the first figure, okay. At a certain distance, for example, distance 2, this is the certain deformed body and distance. Okay, and the condition that we have to follow is, number one is the loading must be linearly related to the stress or displacement that is to be determined. So best, the loading should be proportional to the stress. Okay, you learn about the pressure equal to F over A. Okay, when pressure is high, the force will be high as well. So this is the basic condition if you want to use this principle of superposition. Okay, so it should be linearly related. So P is related to the F. Okay, and then the second thing is that the loading must not significantly change the original geometry or configuration of the member. So the loading, which is P, okay, must not significantly change. So there is no significantly different. The changes will be happen, but not significantly high. Okay, and the original geometry will be not significantly changed lah. Okay, this is the principle of superposition. So later on in the discussion, in the exercise, I will show you on how to apply this principle to solve the problem. Okay, all right, so we move to the next one. So how I can move the slide. Sorry. How to move the slide. Okay. Okay, the second one, the second part of this video is about the statically indeterminate axially loaded member. So from here, actually there are some cases that we cannot use equation of equilibrium. If you still remember, the equation of equilibrium is the summation of forces must be equal to 0, either x or y, okay? Okay, and also the moment lah. So this is the equation of equilibrium. So some cases we cannot use these three formulae, okay, to solve the problem. So if cannot use this formulae, then we have to create our own equation lah. Okay, so if you still remember in static and dynamic course that you learn in year 1, so there is one subject, there is one topic that you have to find the unknown value, which is force lah. Okay, and the equation, the number of equation is based on the unknown value. So if the forces having 3 unknown value, so means that you have to create, you have to establish 3 equation. Okay, so these are the basic things. So if you have 2 unknowns, then you have to have at least 2 equation. Okay, if you have 4 unknowns, you have to create or establish 4 equation. Okay, so same goes to this solid mechanic, where if you use only equation of equilibrium, maybe with 2 unknowns you only have 1 equation. If you use equilibrium, I mean equation of equilibrium. So how to generate another equation? So this is the thing that you will learn in this slide lah. Okay, so what is statically indeterminate? A member is statically indeterminate when equation of equilibrium are not sufficient. As I mentioned to you, if you have 2 unknowns, but using the equation of equilibrium, you only have 1 equation. So this is not sufficient to solve the problem. So you have to have 2. And number 2, you should introduce by yourself. Okay. So when equation of equilibrium are not sufficient to be determined, so you have to have a method or illustration to add another 1 equation. So what makes different between the statically indeterminate and also the statically determinate? So just remember the determinate. So means that the root word is determined. Okay, so the root word is determined. So means that we can determine the equation based on the equation of equilibrium. So this one is statically determinate. But if indeterminate means that we cannot determine okay, the equation based on the equilibrium equation. Okay, so back to this one, statically determinate means that bar is fixed. For example, bar is fixed supported at one point, one end, and is subjected to axial load force. This one is very straightforward. When you have a bar like this one, so at the floor, okay, bar is on the floor, so you have this only point load P. Okay, this is example number 1. So bar is fixed supported at only one end and is subject to an axial load force. So this one is already explained in example 1, if I'm not mistaken. Okay, in example 1, where we have a force, okay, the bar or the object is on the floor, so we can use the equation of equilibrium to solve the problem. Okay, and then for the determinate condition, the force equilibrium system, okay, is sufficient to find the reaction at fixed support. Okay, so we can use this formula lah. Okay, as I mentioned before. And how about the statically indeterminate? So number one, bar is fixed at both ends. So this is only example, yeah. There are many cases. One of them is bar is fixed at both ends. Then two unknown axial reaction occur. So the figure showing you where the bar is fixed at both sides, the top and the bottom one. So it will be fixed here. I make it this same symbol. So this symbol representing the fixed position. Okay, so if this case happen, then means that this one is statically indeterminate. Okay, where we only have one equation only to solve the problem. Okay, and number two, the condition is that force equivalent equation is not sufficient lah. Okay, so we only have one equation. Okay, if you have two unknown, which is you cut it here, you cut it here, or you have a FB here, you have FE here, so this is two unknown. So if you have two unknowns, then you have to generate two equations. But in this case, using the equilibrium system, equilibrium equation, we only can generate one equation. So this is the problem happen. So how to do it? This way. Okay, when the bar is fixed at both ends, then two unknown axial reaction occurs. Okay, so this one I already explained in the previous one. So you just draw um, the FBD. Okay, the first FBD, of course, you just eliminate all the outsource. Okay, all the reaction or all the wall, the floor, so you just remain with the bar only. So when you have the bar having this force, external force, okay, you will have the internal force at the joint. So joint A and joint B lah. So joint A here will be acting upwards, because when you pull down the what do you call it, the bar, okay, the top one will be having reaction to pull. Okay, to pull. So we have F A lah, for example. And then for the side B will be opposed to the reaction force, will be opposed to the external force, which is upward, like this one. Okay, we will be have BC lah. Sorry, FB. Okay, FB. So this is the general, or we call it FBD overall. Okay. So from the FBD overall, you can generate the equation, okay, using the equilibrium equation. So you just play around with the equilibrium system for the y-axis, okay, you will get this formula, okay, where upwards will be positive, should be positive, okay. So we have FB plus FE minus P equal to 0. So this is the first equation. So since we have two unknowns, which is FB and FA, okay, unknown, this is unknown, okay, unknown. So you have two unknowns means that you have two equation, but at the moment you only have one. So how to do? That's why this subtopic is introduced to you. So we can use the method on how to develop the second equation. So how to do it? Okay, from this original body, let me erase this one. Okay, let me erase this one. So from the original FBD, I mean FBD, overall FBD. Okay, this is overall FBD. You can divide this FBD into two FBD, small FBD. So FBD one is the segment AC. We call it FBD for segment AC. Okay, so you cut it here lah. You cut it here. So you cut it here. Okay, the second one is FBD for segment CB. Okay, So you cut it here, you will get here. Okay, so once you have this segment, then you can determine the internal load. Okay, so the internal load here in the beginning, we have this FA. When you cut it at AC segment, we have internal load, which is FA as well. Okay, same goes to FB. So the initial one is FB here at the bottom. When you cut it at the center, we have the internal load FB as well. Okay, as simple as that. So let me erase this one to avoid confusing. So once you have this FBD, you can proceed to generate the second equation. Oops, why this happened? Okay, so again, I already explained where is the Fy, where we get the Fy. Oops, I'm not sure what's wrong with my iPad here. Let me try to fix this one. Okay, so in order to establish an additional equation need for solution, it is necessary to consider the geometry of deformation. So specifically, the equation that specifies the condition for displacement is referred to as a compatibility. So we have to have a compatibility condition where the easiest way to understand is we have to make sure that it is a comparable or compatible. Okay, I will explain you later. Okay, a stable compatibility condition would require the relative displacement of one end of the bar. Okay, we have two end, which is top and bottom. So we just choose only one. Okay, with respect to the other end to be equal to 0, since the end support are fixed. So based on this case, this original body, we can assume that even we have the external load applying at the center, but in the end of the day, the rod will be static forever, not forever lah, static here, static there, with no displacement. Okay, because it is fixed. So any force that acting that into the body will not affect the condition, will not affect the geometry. So the deformation will be 0. So that's why we have the delta E relative to B is equal to 0 always. Okay, and this is the compatibility condition for this case. So from this delta equal to 0, we can generate another equation. So I will show you another one. Okay, load displacement relationship, you know that the delta equal to pi, so you can use this equation to generate second equation. Okay, internal force in segment A, C equal to plus FA. This one is load displacement relationship. When you have the compression, the displacement will be negative. And of course, the force will be negative as well, the direction. When you have the tensile, okay, let me draw. You have the compression, okay, the deformation, okay, the deformation will be negative. When you have tensile like this one, the deformation will be positive. So same goes to F. So F, if deformation is positive, F will be positive as well. This one, F will be negative as well. So the negative sign is only indicating the direction, okay? And then for the AC, since FC is tensile, that's why the F is positive. But for the CB, since the force, the body is compressed, then the CB should be in negative force. So this is the easiest way to understand. So once you have this understanding, you can substitute this information to the equation. But you have to understand that the deformation is not occur, means that the displacement is always 0. So how to get the 0 value? We have this equation. So means that the delta A minus delta B must be always equal to 0. Okay, must be equal to 0. So I just make it a simple delta A to make you understand. and the second one is delta B to make you understand. So this is the way. Okay, so just substitute the value of delta A, which is pi minus pi and equal to 0. Okay, and of course AE will be same lah for both sides, segment AC and segment CB. So area and also modulus will be same. Only the difference is for the F and L. Okay, so once you have this formula, number 2, just substitute all the information of F and L into the equation. Okay. Okay. Sorry. Before that, let me erase this one. Okay. Okay. Once you have this information where AE is constant, we can solve the both equation for reaction like this way. Okay. So back to the first equation. Sorry. Back to the first equation, you just substitute the equation, the first equation, substitute 1 into 2. When you substitute the equation number 1 into 2, okay, you will get this formula. Okay. All right. Okay, so this is the condition where we have the statical indeterminate model condition. So you have to apply the deformation condition to get another equation. And the next one is the force method of analysis for axially loaded member. So once you have that condition, this is the way that we can generate the method for the analysis. Okay, again the same figure here. Okay, just want to show you how we can generate the equation again. So the first procedure is that choose any one of the two support as redundant. Temporarily remove its effect on the bar. So in this case, we only choose the bottom part. Okay, the bottom part. Okay, choose anyone. So if you want to choose the top part, also can, no problem. But in this case, we just showing you on how to choose, on how to use the bottom part to generate the equation. So we choose the bottom part. Okay, and we remove the effects on the bar. Means that the effects is the floor. Okay, so in this case, once you remove, we can imagine that the bar will be having displacement when we have the external force of P. So really indicate that the support is no need to hold the bar, okay, in stable condition. That when it's removed, the bar becomes statically determinate, means that we have delta P here, as I mentioned. Okay, so but in order to counter again the displacement, we have to introduce another displacement to make sure that it is equilibrium. Okay, equilibrium system. So we have this condition where the delta B is exists. Okay, so when number 1 plus number 2, okay, it will become again the original shape like this, that one. Okay, so this is the assumption. So if you still remember in static, we learn couples. Okay, couples also apply the same method. Okay, also apply the same method to get the equation. Okay, once you have this procedure, we can generate the equation from this one. Okay, where if the load P causes B to displace downward by amount of delta P, direction FB must displace at the end of B of the bar upward by amount of delta B. So as I mentioned to you previous slide, so we have delta P, delta P and B. Delta B should minus delta B will be equal to 0 lah. Okay, so this is the total data lah. So delta should be always to 0. Okay, once you have this relationship, we can simply put the equation of delta. Delta again, pi. Okay, put it into the equation. Okay, you will have the displacement, load displacement relationship. Okay, all right. So this is the procedure on how to generate. Okay, this is the summary of the subchapter 4.4 and 4.5. So the first procedure is, of course, you have to draw a BD or member to identify all forces acting on it. So as mentioned in the previous slide, the first part is to draw the overall FBD from here. So you have a FBD overall where you have the internal load. This one is the external load, okay, and this is the internal load as well. So you draw the first FBD. So once you draw the first FBD, you only get one equation. So once you have this equation, then means that it is a statically indeterminate. Okay, so this is the first step. The second step is that write the equation. Okay, the second step already explained. Write the equation. So you found only one equation. If unknown, number 3, yeah, if unknown reaction of FD greater the number of equation, then problem is statically indeterminate. So if let's say the unknown reaction, okay, the previous case having 2, which is FA and FB, but the number of equation here only one equation, okay, so means that it is a statically indeterminate. Okay, and if you found this one, you will proceed with the second the next method, which is draw a diagram to investigate elongation or contraction. Okay, so if you found 2 unknown but you have one equation, or 3 unknown you have 2 equation, then you have to use elongation or contraction or deformation. Okay, and then express compatibility condition, and then you will have another equation, question number 2 lah. Okay, so this is the summary. So let's proceed to the example. So this is the example. A steel rod shown has a diameter of 5 millimeter. Okay, diameter is given, okay, D. So we can use this to calculate area. Okay, it is attached to the fixed wall at A, and before it is loaded, there is a gap between the wall at B prime. Okay, the gap is very small, which is 1 millimeter. And determine the reaction at A and B prime. Okay, you have to find reaction at A. So normally I will write down everything, okay, to make sure everything is clear. So if the rod is subjected to an axial force of P equal to 20 kN, neglect the size of the collar C. So the size of collar C is different with the rod, but we have to neglect it. And take the elastic modulus of stainless steel there equal to 200 gigapascal. So E is given. Okay, A we can get it from D. Okay, so we have to generate equation. Okay, so how to do? Let me proceed to the next one. So of course you have to draw the overall FBD lah. Overall FBD. Okay, and then you determine the internal load, which is the internal load. Okay, let me redraw again lah. So internal load is here. But at point B, we have to understand when internal load is applying to the right side will be pushing. This one is reaction. So the B will be pushing like this one. This one is not, this one you should not memorize lah. You should understand how to make it arrow. Okay. Okay, at point A, when we have force P equal to 20, point to right side. So at point A, try to tend the position, try to stabilize the position, means that we have to pull the 20 kilonewton. So we'll be opposite direction, like this way. So this is the way on how we make a direction of the internal load. Okay, so, oh, sorry, let me erase this one. So once you have this FBD, overall FBD, then you can develop the first equation using the equilibrium equation. Okay, so for this case is Fs equal to 0 lah. Okay, so from this equilibrium system, you will get this. Okay, so normally right side will be positive. Okay, you have this first equation. But if you think there is no other way to use equilibrium system for generating the second and third equation, means that this rod or this system is statically indeterminate. So once we identify the problem condition, then we have to use the compatibility equation. So compatibility equation is this way, okay, where you have to cut segment by segment. Okay, so you cut it at C. So this color C, you cut it here, you cut it here, you will have the first FBD, okay, of AC, okay, for AC segment. Okay, and you cut it here, you will have FBD for CB segment. Okay, so from here again, you have to use equilibrium system to find the internal load, okay, of FA and FB lah, straight away, as I mentioned previous slide. Okay, once you have this one, okay, sorry, again, I have to delete this one to avoid confusing. Okay, once you have this one, you will develop the second equation. Okay, you will develop this equation. Okay, bear in mind that we have value of displacement, which is already mentioned in the question, 1 millimeter there. So you have to use 1 millimeter instead of 0 in the previous example. Okay, 1 millimeter. So you cannot put 0 lah here. It should be 1 millimeter. Okay, and then same equation as it is as previous one, where delta A minus delta B, okay, equal to something 0.001 for this case lah. Okay, so from here, okay, the target is that we have to find FA and FB lah. Two unknown, so means that we have to develop two equation. So we have already two equation. Okay, we have already two equation. Then the other next step is just put the information, the given information, like area here. So area can be calculated using pi r square. Okay, and E also is given 200 gigapascal. So just substitute into this equation. Okay, and the distance is given from the previous slide, okay, where 400 for AC, 800 for CB. So just substitute into the equation, and you will generate the actually the equation number 3 is from number 2, okay, where the equation number 3 is in term of numbers, okay, without unknown, okay, without L and AE unknowns, okay. So from number 3, you just solve it with number 1. So solving 1 and 3, you will get the unknown value of FA and FB directly. So the process, the detail on solution I will not explain because this one is mathematics. Okay, so just substitute the value into the equation, then you will get the answer lah. So I will explaining the way on how to generate equation. Okay, so example 5, having the solution there, you can just go directly to the solution, study by yourself, discuss with your friend. This is example number 5. Example number 6 also, I provide the final answer and also the solution lah. Okay, so you can just study with your friend. And the next one, I will continue in the next video. Okay, the next 4.6 and above, I will continue in the next video. So I think that's all for this video. If anything, please let me know and you can ask me during the physical class. Goodbye.